On July 6, 2026, at 02:17 local time, across the darkened waters of the Sea of Azov, something was already in motion. Russia's Shadow Fleet, dozens of tankers, bulk carriers, and support vessels moving fuel and supplies toward occupied Crimea under foreign flags and cover of darkness, had operated with near impunity for months. These were not ordinary merchant ships. Each was a node in Russia's sanctioned logistics chain, hauling diesel and aviation fuel to a peninsula that could not survive without resupply by sea. Intelligence analysts had estimated the Shadow Fleet was delivering upward of 60,000 metric tons of petroleum product per month into Crimea, enough to sustain Russian armored operations on the southern front and keep Russian Black Sea aircraft flying. The fleet was Russia's lifeline, and it believed the sea protected it. It had no idea that Ukraine had been tracking every vessel, every route, every schedule for 6 weeks. What the Russian maritime commanders did not know was that Ukraine's Unmanned Systems Forces had spent those 6 weeks not just watching, but building the most ambitious naval drone offensive of the entire war. And what would begin dismantling a fleet worth an estimated $4.2 billion in combined vessel and cargo value was nothing more expensive than purpose-built kamikaze drones costing tens of thousands of dollars each. In the next 5 nights, 48 Russian vessels would be struck. The Sea of Azov would never be the same. 17 Magura V5 unmanned surface vehicles launched from concealed positions along the Ukrainian coastline at 0144, cutting through the Azov chop at 42 knots, racing toward the Shadow Fleet's main approach corridor northeast of the Kerch Strait. At the same time, strike units designated Kairos, Raid, and the 1st UAV Center, Ukraine's most experienced drone formations, had already put fixed-wing kamikaze UAVs into the air from launch sites in Zaporizhzhia Oblast. The combined force numbered over 60 aerial and surface drones on the first night alone. The aerial elements flew at 150 feet above the water, skimming below Russian radar coverage, heading toward vessels anchored in the strait approaches and moving into loose convoy formation toward Feodosia. The Magura V5s, riding low in the swell, were closing in from the northwest, from the direction no Russian radar picket was covering. High above, reconnaissance UAVs circled at altitude, feeding targeting coordinates in real time to strike coordinators on the Ukrainian side. The attack force was layered. Lead elements carrying warheads, trailing elements running electronic countermeasures, and a final tier of decoys designed to draw Russian defensive fire away from the primary strikers. It was not a single wave, it was a system. To understand why this campaign mattered, you need to understand what Russia's Shadow Fleet actually was. After Western sanctions cut off Russia's access to legitimate maritime logistics following the 2022 invasion, Moscow built a parallel system. Hundreds of vessels, many flying flags of convenience from landlocked nations or obscure Pacific registries, sailing under shell company ownership structures designed to obscure their Russian connections. These ships hauled crude oil out and brought refined fuel products in. For Crimea specifically, the Shadow Fleet was not a supplement to the supply chain. It was the supply chain. The Kerch Bridge, damaged in previous Ukrainian strikes, had reduced capacity. Rail throughput was constrained. The sea route through the Azov carried a disproportionate share of the fuel, keeping Russian forces operational on the peninsula and in the southern oblasts. Each tanker in the fleet represented not just its hull value, typically between $15 million and $80 million, depending on displacement and age, but the 20,000 to 40,000 tons of petroleum product it carried on any given voyage. Western energy analysts tracking the fleet had estimated that a successful disruption of even 30% of monthly throughput would create measurable fuel shortages for Russian armored units within 3 to 4 weeks. Ukraine's planners understood this. They were not targeting ships. They were targeting Russia's ability to fight. What strikes me about this campaign is how methodically Ukraine turned a tactical capability, maritime drone strikes, into a strategic instrument. This was not improvisation. This was doctrine. I spent weeks going through the open-source intelligence record on this operation, and one detail kept pulling me back. Ukraine didn't just know where the ships were. They knew the vessels by name, by flag registry, by cargo manifest, by crew rotation schedule. The intelligence picture was extraordinary, and it tells you something about how thoroughly Ukraine had penetrated Russian maritime logistics before the first drone ever hit the water. The Magura V5 is the centerpiece of Ukraine's maritime drone fleet, and it deserves a proper introduction. Developed by Ukrainian engineers and refined through 2 years of operational combat experience, the Magura, Maritime Autonomous Guard and Reconnaissance Asset, is a surface drone running approximately 5.5 meters in length, powered by a single outboard motor capable of sustained speeds above 40 knots. Its operational range extends to 450 kilometers from its control station, and it carries up to 320 kilograms of explosive payload in its bow cavity. The detonation system is impact-triggered and can be armed remotely. The hull rides low, deliberately so, presenting a radar cross-section smaller than the wave clutter it navigates through. Russian radar operators, looking for surface threats against the backdrop of Azov chop and spray, had consistently failed through prior engagements to acquire Magura V5s until the drones were within 800 meters of their targets. By that point, interdiction was nearly impossible. What made the Magura uniquely suited to this campaign was not raw speed or payload. It was endurance and autonomy. Earlier versions required near-continuous operator input. The version deployed in July 2026 incorporated waypoint navigation with machine vision terminal guidance, allowing operators to set approach corridors, activate the terminal phase at a predetermined range, and let the drone complete the attack without continuous data link. Critical in an ECM-saturated environment where Russian electronic warfare systems were attempting to jam control frequencies. The aerial component of the campaign used fixed-wing kamikaze UAVs from Ukrainian production lines, supplemented by modified FPV platforms for shorter-range engagements against vessels operating close to occupied coastlines. The fixed-wing systems flew pre-programmed routes, minimizing radio frequency emissions during the approach to reduce their electronic signature. Their navigation combined inertial reference with optical terminal guidance, identifying vessel silhouettes against the water surface in the final kilometer of flight. Against a large tanker or bulk carrier, a single strike carrying a warhead in the 30 to 50 kilogram range was sufficient to rupture fuel storage, disable propulsion, or ignite cargo. Against smaller support vessels, it was sufficient to sink them outright. Here's the part that seems contradictory on the surface. Russia had deployed air defense assets around the Kerch Strait and along the Crimean coastline specifically to counter Ukrainian drone threats. Panzer S-1 systems, Tor M2 batteries, and naval point defense platforms on escort vessels. On paper, that defensive architecture should have degraded a drone campaign of this scale significantly. In practice, it didn't. And the reason comes down to geometry. The Azov Sea is shallow and relatively confined. The Shadow Fleet vessels were not sailing under the protective umbrella of Crimean-based SAM systems. They were transiting the open Azov, in some cases more than 80 kilometers from the nearest shore-based air defense coverage. The escort vessels carried their own defensive weapons, but their radar operators were tracking surface threats from a moving platform in sea states that generated enormous false positive clutter. The Magura V5s were coming in at wave height from multiple vectors at once. The defensive geometry was simply not designed for this problem. Put yourself in the position of a Russian radar operator aboard an escort vessel at 02:30 on the morning of July 7th. You have 47 contacts on screen. Actual merchant vessels in convoy, radar returns from wavetops, possible drone signatures, possible sensor artifacts. You have seconds to make targeting decisions. You have one Panzer mount on the aft deck. You are outnumbered by the attack, and you know it, and there is nothing you can do about it. The planning phase for this campaign had begun in late May 2026, according to Ukrainian military statements released after the operation concluded. The initial intelligence picture came from a combination of sources: commercial satellite imagery tracking vessel movements in and out of Azov ports, OSINT analysis of AIS transponder data, the automatic identification signals that civilian vessels are legally required to broadcast, which Shadow Fleet operators sometimes disabled but not always consistently, and reporting from human sources tracking loading operations at Rostov-on-Don and Taganrog. Ukrainian military intelligence built a target package for each vessel. hull identification, typical route, anchoring patterns, cargo type, and estimated economic value. Route planning for the maritime drones accounted for Russian patrol vessel schedules, the known positions of shore-based radar installations along the Russian and occupied Ukrainian Azov coastline, and bathymetric data, water depth charts, that constrained where the Magura V5s could operate without grounding. The northern Azov, particularly in the approaches to the Kerch Strait, offered the deepest water and the most direct approach to vessels anchored in the strait's holding areas. The launch window of 00-144 on July 6th was chosen for three specific reasons. It placed the strike wave at the deepest point of human attention fatigue in the Russian watch cycle. It provided maximum darkness before nautical twilight began degrading the visual concealment advantage, and it coincided with a weather window that produced moderate swell, enough to increase radar clutter and complicate Russian visual identification of drone signatures, but not enough to degrade Magura V5 performance. One detail that stuck with me when I worked through the operational record. The Ukrainians struck on 5 consecutive nights. Not one night, not a single mast wave, and then withdrawal. 5 nights in a row. That sustained operational tempo implied a logistics and maintenance capability that most observers had not attributed to Ukraine's drone forces. The ability to regenerate strike packages night after night while continuing to refine targeting based on the previous night's battle damage assessment. It also implied something about Russian response capacity. After night 1, Russia knew the attacks were coming. They had 5 nights to stop it. They couldn't. Now let's walk through the strike sequence night by night, because this is where the operational picture gets genuinely extraordinary. Night 1, July 6th into the 7th. The opening wave targeted vessels in the Kerch Strait approaches and the anchorage northeast of the strait where Shadow Fleet tankers typically waited for convoy formation before transiting. 17 drones engaged. Confirmed strikes on 9 vessels, including 3 tankers. The Matros Puzanik, the Teeny, and a third vessel identified only by hull number in initial Ukrainian reporting. A Ro-Ro ferry, operating on a route between Kavkaz port on the Russian side and Crimea, and 2 bulk carriers carrying grain eastbound. The ferry was a particular prize. It had been providing logistical support to Russian military personnel rotating through Crimea, and its loss disrupted that personnel movement chain. Secondary explosions were reported from at least 2 of the tanker strikes, consistent with fuel cargo igniting after hull penetration. Satellite imagery acquired the following day showed 2 vessels stationary and listing in the eastern Azov, 1 vessel beached on the Russian coastline east of the strait, and oil slicks extending several kilometers downwind from strike locations. Russian official media did not acknowledge the strikes on night 1. The silence itself was informative. It indicated the scale of damage exceeded what Moscow was prepared to admit. Night 2, July 7th into the 8th. Ukraine launched a second wave before Russia could reorganize its convoy routing. Strike units Kairos and Raid committed additional Magura V5s alongside aerial kamikaze UAVs targeting vessels that had anchored further east in the Azov, outside what Russia apparently believed was the practical operational radius of Ukrainian maritime drones. They were wrong. 10 additional vessels struck. The running total reached 19. What the Russian maritime commanders had not anticipated was that Ukraine had pre-positioned drone launch assets along multiple points of the Ukrainian Azov coastline. Not a single launch site, but a distributed network of release points that compressed the response time available to Russian escort vessels. By the time Russian patrol craft responded to contact reports from the first wave, the second wave was already inside their defensive perimeter. Here's the take that might generate some debate. Russia's decision not to provide heavier naval escort for the Shadow Fleet was not a resource failure. It was a political calculation. Committing Russian Navy surface combatants to protect commercially flagged Shadow Fleet vessels would have made explicit what Moscow was officially denying, that these ships were operating in direct support of Russian military logistics. The Shadow Fleet's value depended partly on its deniability, and that deniability made it structurally vulnerable to exactly the kind of attack Ukraine executed. Night 3 produced the largest single-night strike count, 14 vessels. By this point, Russia had attempted to reroute its convoy traffic through the northern Azov, staying closer to Russian-held coastline and the air defense coverage available from shore-based systems near Berdyansk and Mariupol, Cities Russia had occupied since 2022. Ukraine adapted. Aerial drones launched from positions in Zaporizhia Oblast flew longer approach routes to reach the repositioned fleet, and additional Magura V5s launched from Ukrainian-held coastline covered the revised approach corridors. The operational obstacle on Night 3 was weather. A pressure system moving through the northern Azov produced wind speeds that approached the upper operating threshold for Magura V5 guidance stability, around 25 knots. Ukrainian drone operators made a calculated decision to launch anyway, accepting reduced terminal accuracy in exchange for maintaining operational tempo. The bet paid off. Of the 14 vessels targeted that night, 11 confirmed strikes were logged in subsequent OSINT analysis. Nights 4 and 5 extended the campaign to vessels that had sought refuge by anchoring close to Russian port facilities at Rostov-on-Don and Taganrog, a distance from Ukrainian-held territory that would have been operationally impossible for Ukrainian maritime drones 12 months earlier. The extended range reflected upgrades to Magura V5 navigation endurance, and, according to Ukrainian military sources, the use of relay positioning for control signals that extended effective command range beyond the previous operational ceiling. By the end of Night 5, the confirmed strike total stood at 48 vessels. Not 48 sinkings. Battle damage assessment took days to complete, and some vessels were damaged rather than destroyed. But 48 confirmed weapons impacts on 48 separate hulls. Would Russia's Shadow Fleet have survived this campaign if it had received proper naval escort from the Russian Black Sea Fleet? Drop your answer in the comments, because the real answer is more complicated than it sounds. The parallel blackout campaign, running alongside the maritime strikes, added a second dimension to the operation that deserves specific attention. On the same nights that maritime drones were hitting vessels in the Azov, separate Ukrainian strike assets targeted electrical infrastructure feeding Crimea from the Russian mainland. Substations along the power corridor through the Kerch region took multiple strikes. The energy bridge, the high-voltage transmission line that carries mainland Russian electricity into Crimea across the strait, suffered damage that Ukrainian energy infrastructure sources assessed as significant. The dual campaign was not coincidental. It was designed to simultaneously degrade Russia's ability to receive maritime resupply and to stress the electrical grid that Crimea's military facilities depended on. Radar systems, communications infrastructure, drone detection networks, all require stable electrical power. Hitting the power supply at the same time as the maritime supply chain was an attempt to compound each strike's effect. Western analysts tracking the campaign estimated total Russian losses, vessel damage and destruction, cargo loss, and infrastructure damage, at between $3.1 billion and $4.8 billion across the 5-night operation. Even at the conservative end of that range, it was the single most expensive 5-day period for Russian military logistics since the war began. Individual vessel losses ranged from an estimated $18 million for smaller support craft to over $90 million for the largest tankers, with cargo value adding substantially to each figure. 3 vessels were assessed as total losses. 19 more were assessed as requiring extended dry dock repair, effectively removing them from the Shadow Fleet's operational rotation for months. The Russian response in the days following the campaign was instructive. Moscow rerouted remaining Shadow Fleet traffic to longer approaches through the eastern Azov, adding transit time and fuel cost to every cargo run. Additional patrol vessel presence was deployed, at some expense to Russian Black Sea Fleet operational commitments elsewhere, and Russian state media began carefully to acknowledge incidents involving vessels in the Azov without specifying the nature or scale of the incidents. What's most surprising about this campaign isn't the scale of the damage. It's how long the Shadow Fleet had operated without facing a threat of this kind. For more than 2 years, Russia's maritime logistics chain through the Azov had functioned with relative security, occasionally disrupted but never systematically targeted at this operational tempo. Ukraine had been developing the capability, refining the doctrine, accumulating the intelligence picture. July 6th was not a sudden decision. It was the execution of a plan that had been years in preparation. The implications extend beyond the Black Sea theater. Ukraine's Unmanned Systems Forces have now demonstrated the ability to conduct sustained multi-night offensive campaigns against dispersed maritime targets at ranges that strain the concept of a safe operating area for any Russian logistics vessel in enclosed or semi-enclosed waters. The Azov is demonstrably hostile to Russian maritime logistics now. The question Russian military planners face is whether the Black Sea itself, larger, deeper, further from Ukrainian drone launch positions, but also home to more valuable Russian naval assets, will be next. Ukrainian drone doctrine has evolved from a reactive, improvised capability into something that military analysts are beginning to describe as a genuine operational arm. Not a supplement to conventional forces, but an independent instrument of strategic effect. The July 2026 Azov campaign is the clearest demonstration yet of that evolution. 48 vessels, 5 nights. A logistics chain strangled not by a single decisive blow, but by sustained, adaptive, relentless pressure. The Sea of Azov is no longer a safe corridor for Russia's shadow fleet. What happens to the fuel supplies that no longer reach Crimea, and to the Russian armored formations that depend on them, is a question that will answer itself in the weeks ahead.